You know, what if I told you that our planet has been hiding a solar battery, the size of a continent? I'm serious, a battery that never needs a recharge, never runs out, and could, just maybe, power our entire civilization. And it's not buried deep underground or floating out in space, it's the very thing that covers over 70% of our world, the ocean.
We all know the fundamental challenge with renewables, right? Solar and wind are fantastic, but when the sun goes down or the wind stops blowing, well, the power cuts out. It's this problem called intermittency, and it's the single biggest hurdle to a truly carbon-free grid. But what if the solution has been staring us in the face this entire time?
And this really gets right to the heart of it. On one side, you've got our current renewables. They're incredible, don't get me wrong, but they need expensive batteries or fossil fuel backups to be truly reliable. And on the other side, you have the tropical ocean. It's a massive natural battery that stores solar energy day and night, giving us constant, stable power 24/7. Okay, so how does this giant planetary battery actually work? Well, the science behind it is surprisingly elegant, and it all boils down to one simple concept: a difference in temperature. It's something called the thermal gradient. See, the tropical sun heats the ocean's surface to a really pleasant 25, maybe 30 degrees Celsius. But just a kilometer below that, it's a totally different world of near-freezing water, around 4 degrees. That massive temperature difference is basically like the positive and negative terminals of a battery. It's a constant, untapped source of potential energy. And here's the magic number. You need a temperature difference of at least 20 degrees Celsius. That's the key. That's what unlocks this technology, called ocean thermal energy conversion, or OTEC. And that exact temperature gap exists reliably day and night all year long across a massive belt of our planet. Now, I know what you might be thinking. Okay, but what's the efficiency? And you'd be right to ask. It's low, only about 3 to 4%. But here's the game changer. The fuel, the warm ocean water itself, is completely, totally, and infinitely free. You don't have to mine it, you don't have to ship it, you don't have to burn it, you just have to move it. So if the ocean is the battery, how do we plug into it? I mean, how do we actually turn a simple temperature difference into the electricity that powers our lives? Let's take a look at the tech. This is the most common design. It's called a closed-cycle system, and it's a really elegant four-step loop. First, you take that warm surface water and use it to boil a fluid like ammonia, which, turns to gas at a really low temperature. Second, that pressurized gas expands and spins a turbine, and boom, you're generating electricity. Third, you bring up cold water from the deep ocean to cool that gas, turning it right back into a liquid. And finally, that liquid just gets pumped back to the start to repeat the cycle. It's a continuous, self-contained engine powered entirely by the ocean. Okay, look, constant clean power is already a huge deal. But this is where the story gets truly incredible. Because an OTEC plant isn't just a power plant. It's more like a resource recovery center. And the electricity it generates, well, it might not even be its most valuable product. Yeah, let that sink in for a moment. What could possibly be more valuable than a constant, infinite source of clean energy? This is what's called the OTEC multiplier effect, and it's what could make this technology an absolute game changer for entire nations. That cold water, even after it's been used to make power, is still incredibly valuable. It can provide large-scale air conditioning for entire coastal cities, which would dramatically cut their electricity demand. The process can also create millions of gallons of fresh drinking water. And get this, the deep water is packed with nutrients, making it perfect for creating huge aquaculture farms. And to top it all off, you can use the electricity to create green hydrogen and ammonia right there at sea, the carbon-free fuels of the future. Now, this all sounds amazing, right? But of course, it's not easy. Tapping into the power of the deep ocean means we have to overcome one of the greatest engineering challenges on the planet. The entire system really hinges on one critical piece of hardware, the cold water pipe. It's been called a skyscraper-sized straw, and honestly, that's the perfect way to picture it. It's just this colossal structure that has to hang from a floating platform and somehow endure the immense pressures and currents of the deep sea. To get to that icy cold water, this pipe has to reach a depth of 1,000 meters. That's over 3,000 feet straight down into the abyss. And to move enough water for a commercial-scale plant, this thing needs to be about 10 meters or 30 feet in diameter. The scale of just this one component is, well, it's just staggering. So it's no surprise that building something on this scale means the upfront capital cost, or CapEx, is very, very high. But And this is a big but. Once it's built, the ongoing operational cost, the OPEX, is incredibly low. The reason's simple. You never have to pay for fuel. For island nations that right now rely on expensive imported diesel, this economic model is a potential game changer. Now, let's be realistic. OTEC isn't a silver bullet for the entire planet. It has its limitations. First, there's the 20-degree rule. It only works in that tropical belt. Second, it makes the most economic sense for island and coastal nations. And finally, we have to be responsible. That nutrient-rich deep water has to be managed really carefully to protect the surface marine environment. For decades, OTEC has been called the sleeping giant of renewable energy. Well, it looks like that giant is finally starting to wake up. This isn't just theory anymore. It's actually happening right now. Pilot projects are already proving this technology works. Japan has had a plant running successfully in Okinawa for years. Here in the US, Hawaii's test facility is already connected to the power grid. And looking ahead, South Korea is developing a floating plant for the island nation of Kiribati. The momentum is definitely building. There's a quote that just captures this whole idea so beautifully. The power of the sun, stored in the depths of the sea, waiting for us to lower a pipe and drink from the infinite. It's an almost poetic way to describe this incredible, incredible vision. So when you look at it, the physics are undeniable. The engineering challenges, while they're massive, they are solvable. And the potential benefits, constant clean power, fresh water, food, fuel, they're just immense. The technology isn't science fiction anymore. So the only real question left is, are we ready to invest in it?